So today what we're going to be doing is we're going over part 4 of absolute value equations. Now, what we've seen up until this point is that any values that we get are either they both work or neither of them work. And we're going to see today that sometimes we'll get one that works and sometimes we'll get one that doesn't. So the starting one is going to be a review of what we've historically done. And now, basically what we're going to do is we're going to isolate our absolute value equation by getting rid of anything that is not inside the brackets on this side of the equation. Cancels that out. And I'm left with an absolute value of 2x plus 3 is equal to x plus 2. Combined like terms over there. Now, at this point, still like normal, we're going to split. I'm going to split into one that is the exact same thing. So I'll have a 2x plus 3 is x plus 2. This is what we call the positive split, meaning nothing's changed. I'm taking the positive value. Then I have what we call the negative split, which is 2x plus 3 equals negative x minus 2. I basically take each one of these and change their signs. Doesn't matter if they're plus or minus. I'm not making everything a negative over here. I'm just changing both the signs. Then what we do is we go ahead and we solve each side. Now for this, I'm going to combine my x's, cancel those out. I'm left with x plus 3 is 2. Then I subtract my 3. That cancels out. And I have x is equal to negative 1. That's my first answer that I'm going to need to check. My second option, when I add my x, that's going to cancel out. I have a 3x plus 3 is negative 2. I subtract my 3, and I get 3x equals negative 5. And my final step is divide by 3. Let's extend this down a little bit further, which leaves me with my second answer of x equals negative 5/3. So those are the two answers that I'm going to have to check. So what I'm going to do is I'm going to take each of these two answers and I'm going to plug them into the equation that I split to see if they work. Now remember, these top two, nothing crazy is going on. They're either both going to work or they're both not going to work. So if I plug in a negative 1 into my equation right here, I'm going to get absolute value of 2 times negative 1 plus 3 equals negative 1 plus 2. And I'm going to solve this out. So on the left hand, I'm going to combine everything over here. Negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. The absolute value is 1. So I'm going to check and see, does 1 equal what's over here on the right? Negative 1 plus 2 is 1. So does 1 equal 1? Yes, it does. So I know this answer has been validated. I do the same to my second answer. I'm going to plug that into my split equation. So 2 times negative 5/3 plus 3 is equal to negative 5/3 plus 2. And I'm going to split each side and see, do they work? So 2 times negative 5/3 is going to give me negative 10/3. Now, when I want to add 3, I'm going to have to convert this to something that's over 3, so that's going to give me a 9/3. Negative 10 plus 9 is negative 1/3, which gives me a positive 1/3. So I'm going to check to see, does 1/3 equal what's over here? Well, I'm adding the two of these. 2 converted to a third is going to be negative 5/3 plus 6/3, which also gives me a 1/3. And so yes, my second answer checks out, which means both of these have been validated. So now that I've got both of these validated, let's go ahead and try one where only one is going to work. And so the process is going to be the same. I'm going to isolate my absolute value, add 4y plus 4y. And now what I notice is that I have a constant and a variable. These two terms don't combine, so I leave them separate. 3y plus 4 is equal to 4y plus 3. Again, they don't combine, so I leave them separate. Which brings me to the point of which I last split my equation. Because my absolute value is isolated, I'm going to split. I'm going to rewrite it. 3y plus 4 is equal to 4y plus 3 with no changes. And I'm going to rewrite it. 3y plus 4 is a negative 4y minus 3 with changes. So there's my positive split and there's my negative split. I'm going to solve both of these. So I know that with my first one, subtract 3y minus 3y, that goes away. 4 equals y plus 3. I subtract my 3. 3 goes away, and I'm left with y equals 1. There's my first answer that I'm going to need to check. My second one, when I start working this, let's see, I'm going to add 4y, add 4y. Now the reason why I add 4 instead of subtracting 3 is I like positive coefficients. No reason really at all. It can work either way, but I like positive coefficients simply because it makes my life easier and it's less prone to small little errors. Get rid of that 4. 7y is negative 7. And then my last thing is when I divide by 7, I know that 7 divided by negative 7 is going to give me a positive 1. Perfect. So those are the two answers that I'm going to need to check. So I'm going to plug them in. I'm going to plug this and this one into the equation that I split, which is right up there. I'm going to see, do both of these work? And so I'm going to write out my first equation. So 3. And both times I see a y, I'm going to plug in a 1. And I'm going to solve it. The left side, 3 times 1 is 3 plus 4. That's the absolute value of 7, which is 7. On my right-hand side, I get 4 plus 3, which is 7. And so yes, I know my first one works. So far, this looks pretty normal. So I'm tuned into this one because I know what the point of today is. So I betcha when I plug this one in, something weird's going to happen. And let's take note. So 3 plus 4 equals 4 plus 3. I'm going to plug in my negative 1. Just in case you can't realize that that is a negative right there. And so I'm going to simplify my right-hand side first. So negative 4 plus 3, which is negative 1. I automatically know that no matter what I get my absolute value, I am not going to be able to get a negative 1. So I already know that this isn't going to work. So really at this point, I could go ahead and cross this answer out. But I'm going to go ahead and finish this just to prove that it doesn't work. 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. The absolute value is 1. And does 1 equal negative 1? No, which means that this answer does not work. The only acceptable answer for this is going to be positive 1. This is a false positive. It appeared as though it could solve the equation, but that absolute value bracket threw it for a loop. So let's take a look. So what I want you to do, taking the idea of the first one, try the second one out and see how well you do. Pause the video, resume it when you're done. Okay? So let's go ahead and take a look at how we did. So I'm going to add an m to both sides. Cancels out over here. So I have 4m plus 3 is equal to 5m plus 4. My brackets are isolated, so I'm going to go ahead and split. I'm going to split over here and rewrite the positive split. 4m plus 3 equals 5m plus 4. And then I'm going to do the negative split over here. 4m plus 3 negative 5m minus 4. So I have split 1, and I have split change. For split 1, I'm going to subtract 4m from both sides, and I'm going to get 3 equals m plus 4. Subtract my 4, and I get m equals negative 1. There's the first answer that I'm going to need to check. So now I'm going to try my second one. What is the second answer I need to check? And again, I could subtract the 4m. That'd give me a negative coefficient though, and I'm not necessarily the biggest fan of negative coefficients. Oop. I like to have my coefficients be positive whenever possible. You may be different. You may do things slightly differently than me, and that is okay. Get rid of the 9 by dividing by 9, which means that, m is another fraction. So m equals negative 7/9. Okay? So at this point, I'm going to give you a second chance. If you want to pause it and see if you can't check and see which ones works. If not, if you choose not to pause, we're going to go ahead and we're going to try and plug these in. So I'm going to plug this one and this one into the equation that I split. Now, another question you might ask is, can I plug them into the original equation? Yes, but I would have to plug them in 1, 2, 3 times, where here I only need to plug them in twice. So I'm going to choose the path of least effort, plug it in right there. So 4 plus 3 equals 5 plus 4. And at this point, I'm plugging in the negative 1. I'm going to see what I get. Simplify the right-hand side, negative 5 plus 4. Again, I notice that this, I don't actually need to go any further. I know that this answer will not work out no matter what, because an absolute value can never equal a negative, and this answer will not succeed. So really at that point you can stop. I'm going to go ahead and flesh the rest of this out just to prove it. Negative 4 plus 3 is negative 1. The absolute value is 1. We know that 1 does not equal negative 1. So we were correct. So now let's try the second one. So I'm going to plug my negative 7/9 into my equation. So 4 plus 3 equals 5 plus 4. Negative 7/9, negative 7/9. Awesome. So 5 times negative 7 is negative 35/9. If I want to convert this to a ninth, 4 by 9 is 36/9, which gives me a positive 1/9. I'm going to test that. So it's a positive answer, so there's a chance that this could work out. Let's give it a shot. So 4 times negative 7 is negative 28/9. If I want to convert this 3 to a ninth, 3 times 9 is 27. That's going to give me a negative 1/9, which is a 1/9. And yes, in fact, 1/9 does equal 1/9. That checks out, which means my second answer works. So out of 2 possible answers, 1 works, 1 does not. And there we go. Okay, so today we're going to be graphing coordinates. Now, the idea of graphing coordinates is that they're always shown in a set of parentheses with an x, comma, y. The x always comes first, the idea being that coordinates are always listed alphabetically, and x comes first in the alphabet. So, 2 things about this. The first number tells us how far left or right we're going to go on a graph, one way or the other. If that number is negative, we're going to be going to the left. If it's positive, we're going to be going to the right. The second number in the parentheses is our y value. That's going to tell us how far up or down, up being if it's positive, down being if it's negative. So what we're going to see right here is that on each graph, we always have an x and a y-axis. The x is always shown on the left and right arrows, which gives you the hint that my first coordinate is going to be left or right. The y is listed on the up-down axis, which tells us that the y value is going to be up and down. So when we look at something like 5, 1, that positive 5, which comes first, is going to be a rightward motion of 5. So we're going to be going right by 5. Whereas the positive 1 is going to be an upward motion of 1. And so we're first going to go right by 1, 2, 3, 4, 5, and then up to 1. And we're going to graph that. Unlike this one, where my 5 is negative, a negative 5 just means it's not right, it's left. And my negative 1, which comes second, is not up, it's down. So they still show left and right motion, they still show up and down motion, but a positive, negative just means different directions. So for this one, I'm going to go left 1, 2, 3, 4, 5, and down 1. Cool, so there's my 2 points. Now, the only thing that we'll need to include, because I have more than one point on the graph, and whenever I have more than one of anything on a graph, I have to label it. So I'm going to list this one as 5, 1, and I'm going to label this one as a negative 5, negative 1. There we go. And that's that. So most of what we're going to be doing today is practicing exactly what we just saw there. Except for I'm going to switch this to, let's say, make it blue, so it sticks out a little more. My negative 2, positive 4 of my first coordinate. Remember, my first number is my x value, which tells me left and right. Negative means I'm going to be going left by 2. My positive 4 means up or down, so I'm going to be going up by 4. So I'm going to go left 2, up 4, and I'm going to put a point right there. I have the same 2 values but different signs again. This time my positive 2 is going to tell me to go right by 2. My negative 4 is going to tell me to go down 4. So I'm going to go right 2, down 4, and pop a point right there. And again, because I have more than one point on my graph, I'm going to label which one is which. This is my 2, negative 4, and my upper one up here is going to be my negative 2, positive 4. And that's it. And so, likewise, even if the number is neither positive nor negative, like a 0, the process still works exactly the same. If I have a positive 4, 0, the first number is going to tell me I'm going to the right by 4. The 0 tells me I'm not moving up or down. So I stay. There's no up or down. If I can spell up or down, that doesn't exist. So I'm simply just moving to the right by 4. And I'm putting a point right there. For my other one, the 0 is on the other number. So my 0 right here is telling me there is no right or left. My right or left doesn't exist. However, I do have a positive 4, which tells me I am moving up. So in this case, no right or left, but I am moving up. So I'm going to put one right there, and because I have more than one, I'm going to list the difference between the two. So I have 0, 4, and over here I have 4, 0. There we go. So how about you take what we've just seen and you apply it to something like this. So go ahead, pause the video, try the question, and when you're done, resume the video and see how you did. Okay, so let's see how we're doing. My 2, 4, remember the 2 is telling me left or right, the 4 is telling me up or down. So here I'm moving to the right, and then I'm moving up. So I'm going to go right 2, up 4. My second number, that first number is negative, so I'm moving to the left. The 4 is still positive, so I'm moving left and then up. So left 2, up 4. The third number, again, I have a positive and a negative, so I'm moving to the right because that first number is positive. Second number is negative, so I'm moving down. So right 5, down 1. So the last one is going to be a negative 5, negative 1. That means I'm moving left and then down. So left 5, down 1. and we say we made ourselves a nice little trapezoid. But because I have more than one point on here and I have 4 points, I'm going to have to list which one is which. So -5, -1. This one, well, it looks like I moved left 2 up 4, so it's going to be a -2, 4. This one, it looks like I moved right 2 up 4, so it's a +2, 4. My green one, without even looking at the coordinates, I'm seeing the fact that I moved right 5, down 1, so right 5, down 1. Perfect. So let's go ahead and try the next one. The next one is the same process. So what we notice here, though, is that when I go right and up, I go right 2, up 3. I label it, so 2, 3. The next one, I go left and up, so I go left 1, up 3. It's left 1, up 3. Okay, so I'm labeling it again. So I'm going to go -1, 3. My next point, right 5, up 3. So right and up, right 5, up 3, ooh, right there. So 5, 3. And then my last one, -3, 3. So that's left and up. So left 3, up 3. So -3, 3. They're all along the same line, which means that each one of these all have the same y value. And we're going to see something about that in a future lesson. What happens when they all have the same y value? What happens if they're all in a straight line, just like that? So, looks like this would be a horizontal line. So knowing that what we just did right there, go ahead and knock out the last one, pause the video. When you're done, resume it and see how you did. Okay, let's take a look. Looks like this one I'm dealing with a left and up. So I go left 4, up 5. I'll label it -4, 5. So you can see the negative. My next one is left and down. So left 4, down 1. So -4, -1. I have left and down again. So I go left 4, down 4. So -4, -4. And then my last one is left and I stay. So nothing, neither up nor down. I just go left 4. So -4, 0. And again, just like the one above, this one, they're all in a straight line, except for this time, instead of all sharing the same y, they're all sharing the same x. So if they all share the same x, looks like it must be a vertical line. So there we go. That's it. So today we're going to be graphing coordinates and lines. So where we left off last time was we noticed that some of the coordinates, when they all form a straight line, there must be an easier way to write that. And so today we're going to see exactly that. When we graph our points, what we have here is we have a set of points. I'm going to be going to the right and up. So right 5, up 1. I'm going to be going to the right and down. So right 5, down 1. I'm going to be going right and neither up nor down. And then I'm going to be going right and down again. So right 5, down 4. What I notice is that all 4 of these points at 5, 1, 5, 0, 5, -1, and 5, -4, they all form a straight line. And so the thing that they all share is going to be the x value of 5, which means that if I get an equation like x equals 5, that must mean that I'm dealing with a straight line. So if I go ahead and shade this in, I'm going to put an arrow on each end, and basically what that tells me is that, hey, if I were to keep putting points in this pattern, I could put points like, let's say, 5, 5, 5, 6, 5, 7, 5, 10, way off the paper. The arrow just says there's more beyond what's shown in this graph. Same thing out here. I could say numbers like 5, -5, 5, -10, 5, -50. and keep going all the way down, all the way off the paper. This set of arrows says that, hey, there's more to this graph than what we've shown here. The last thing is I'm going to go ahead and I'm going to label this as an x equals 5. And I'm going to put that at either arrow. Typically, we don't put it in the middle of the graph. We're going to put it towards an end. It's not a hard, concrete rule, but it's just considered polite. And so we know the fact that if I have a set of points that are packed so closely together, we're going to assume that they are continuous. Boom, we have ourselves our first official line. This is a vertical line. There we go. X equals 5 is a vertical line, just like that. Now, similar to the vertical line, we have other things. Now, this, I noticed that they all share a y value, a y of -1. So that means as I go left and down, so left 2, down 1, I go left and down again, so left 4, down 1. Here I go right, but I'm still going down. Right 5, down 1. Here I'm going right and down, right 4, down 1. I notice that I form not a vertical line, but a horizontal line. All of these look like they're in sync with each other, going left and right. So I'm going to go ahead and label these points. This was the -4, -1. This was the -2, -1. This was the right 4, down 1. And this was the right 5, down 1. So after I've got all my points, I'm going to go ahead and connect them with a smooth, continuous line. So what we'll do, I'm going to go ahead and thicken this in. I'm going to draw an arrow again on each end saying I could continue this in each direction. There's more to the graph than meets the eye. And now, typically, like we said, we're going to label it either towards one arrow or towards the other. It's a little crowded over here. So I'm going to go ahead and say y is equal to -1 on this end. Now I've got everything on my graph labeled. And so if all the y values are shared, it looks like the y value is going to create what we call a horizontal line. Cool. And so using what we know, what we're going to see is that on this next one, it looks like I'm not sharing all my y values, I'm sharing my x values, which means I have a common x. And what is the common x? 0. And if I look way back when I have a common x, that's going to be a vertical line. So I bet you my vertical line is going to be right through right here. So I'm going to go ahead and say, if I have a vertical line at 0, bet you it's going to be right there, x equals 0. Let's go ahead and see if the points make what we just drew here true. So let's see. That point is neither left nor right, nor up or down. So it's going to be right there. So far, so good. 0, 0. This is neither left nor right, but it is down. So I go down 2. It's going to be 0, -2. This is neither left nor right, but it's down again. Ooh, we're getting good. Way down here, 0, -5. And then this point is neither left nor right, but it is up. So 0, 3. And yes, when we notice that we have an x equals something and they all share the same x value, that means that all along every possible x value, doesn't matter what the y value is, that's going to be a vertical line. Cool. And so, knowing what we just went over right there, what I want you to do is I want you to try and do something like this. I'm going to give you the equation of a line. The best bet you would have is tell me whether it's horizontal or vertical, then draw it, and give me 4 coordinates off this line. So I'm going to go ahead and ask you to pause the video and resume it when you're done and see how well you did. Okay, perfect. So let's take a look. When I said that x equals something, that means that no matter what my x is the same all the way up and all the way down. It's my y value that's changing. My x stays the same. So that must mean that this is going to be a vertical line. And if I have a vertical line at -1, -2, -3, that means my line is going to be right here. Cool. So I know that I would have x equals -3. And I need 4 coordinates along this line. And now the fun part about this is when I know that my x value is -3, out of my 4 coordinates, I need 2 numbers for each of them, a left-right and then an up-down. Well, I know each of their left-rights is all going to be -3. The only thing that's going to be different is their y values, and I can pick any y values I want. I could pick -5 if I wanted. I could pick +5. I could pick 0, or I could pick anything in between, like a 2. And so this would give me -3, -5. This would give me a -3, +5. This would give me a -3, 0. This would give me a -3, 2. I have boop, 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 those 4 points. Go ahead and label them. -3, 5, -3, 2, -3, 0, -3, -5. Boom. That's it. So even if you didn't get that one, showing you how to work through this one, try it on this one. Instead of x equaling something, we have y is equal to something. So go ahead and give it a shot, pause the video, and resume it when you're done. Okay? So you've probably guessed if that's a vertical line, y equaling something must be a horizontal line. Which would mean I need to go find the value of y is equal to 0 and say, well, y is 5, 4, 3, 2, 1, 0, right here in the middle. And I'm going to draw a horizontal line all the way across. Because I'm on the axis, I'm going to make it a rather thick line just so we can see it. I got my arrows on each end that says, hey, the graph is continuing in each direction. I'm going to label it y is equal to 0. And then I'm going to go through and say, hey, I know that each of my points is going to have the same y coordinate. I know they come x, comma, y, so they're all going to be something, comma, 0. It's going to tell me how far left or right, but I know I'm not going to go up or down because I want to stay right there. So let's actually do this in red. Pink didn't seem like it worked too well. So you can pick anything from 0, -1, 1, and 2. You don't need to pick extreme values. You can pick values that are all right bunched up. So I have -1, 0, I have 0, 0, I have 1, 0, and I have 2, 0. Awesome. There we go. And so the last question we have is kind of an extension of what we just did. It gave us a set of points, and it says, hey, I'm not going to give you the equation for the line. I'm going to make you figure out what the equation for the line is. And so we're going to have to graph this. Let's see, that's right 1, down 1. This is right 2, down 1. And this is no right or left, and it's down 1. Hey, this looks like this is making a horizontal line, which we know a horizontal line, I need to figure out what the y value is. And lo and behold, I know for a horizontal line, all of my y values are equal to -1. So I'm going to go ahead and I'm going to create the rest of this line so I'll be able to visually check to see if my points are on it. So y is equal to -1. I can box that up so you can tell it. I'm going to label my points. This is 0, -1, 1, -1, 2, -1. And now I have the job of listing 3 more coordinates on this line that I haven't already listed. So it looks like I've been going to the right, so I'm going to go ahead and move to the left. I'm going to say 1, 2, and 3 points. I know that each of their y values is going to be comma -1, comma -1, comma -1, because that's the only thing that they share. The thing that I'm going to have to find out is how far left or right I went. Well, here I went left 1. My next one I went left 2. My last one I went left 3. So -3, -1, -2, -1, -1, -1. Boom. And there we go. Okay, so today we're going to be graphing coordinates and lines for the second part. Now, this is going to be, the lines aren't going to be horizontal and vertical, but we're going to have both an x and a y in the equations. And what it's going to do is it's going to create the line with a tilt. And when we have a coefficient in front of a number, we're going to call this the slope coefficient. And this is going to describe the relationship between the x value and the y value. And we're going to expand upon this in later lessons. So when we look at this, I know the fact that this is going to be a line. And I know from what we've done previously, I'm going to have to create a set of coordinates. And typically doing so, I'm not going to create a bunch of coordinates. I'm going to create what we call an xy table. This allows us to plug in values for one or the other and solve for it. Now, stereotypically, we're going to plug in values for x, because later on we're going to learn about what a dependent versus an independent variable is. X is generally considered independent, which means we plug that in first. Today, it's not necessarily going to be important, but when you have a choice between one or the other, generally just plug it in for x. So let's see how it does. If I need to plug in some values, I can plug in anything I want, because realistically, this line is going to go on forever, both in the leftward and in the rightward direction. So I could plug in -1,000,000, but my graph doesn't reach that, so I'm going to do something like -2. So I'm going to plug in things like -2, -1, 0, 1, and 2. Just a couple points to give me a good idea of what's happening. And then for my y value, to figure out what y is when I have this x, is I'm going to use this equation right here, and I'm going to rewrite it. But instead of writing the x, I'm going to write what I said x was. So each one of these, I'm going to say y equals. And for the first one, I'm going to say y equals -2. So I'm going to say y equals -2. For my second one, I'm going to read it as y equals -1. So -1. My third one, y is equal to 0. Y is equal to 1. My last one, y is equal to 2. And so this is going to give me the answer. In this case, it's a very straightforward, no math is being done here. I'm just going to go ahead and repeat the values that I just used. So here's my y values. Took my x, random x's, I plugged them into the relationship, and it's a 1-to-1 relationship. Whatever x is, y is the same thing. Boop, 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 boop. There we go. And so let's go ahead and let's graph this. So this, I'm going left 2, down 2. Going left 1, down 1. 0, 0. Right 1, up 1. Right 2, up 2. And so we see that, again, this is not a horizontal or vertical line, it's a diagonal line. And so if we continue this line on in either direction, we're going to get something that looks like this. And now I'm not going to need to label every single point in every single one of my lines, because that would become tedious depending on how many points you choose to graph yours. Some people use 2, some people use 3. Here we used 5. So what we're going to say is we're going to say, hey, we need to label our line. We have y is equal to x. And we're going to need to label something that crosses an axis. So I'm going to go ahead and pick this point right there and say, hey, this point is at 0, 0. Right there. So I'm going to really quickly write these steps down. So step 1 is we're going to pick some points. We picked -2, -1, 0, 1, and 2. And then we're going to plug them in. Plug them into the equation. So we rewrite the equation with that variable replaced by the number. The third thing that we did was we solved each of them. Solved each one. So we said, okay, with this one, it was just as simple as, well, what is -2? It's -2. The next thing we did was we graphed each point. Graph each one. We put them on a graph. And we said, hey, we noticed they're making a straight line, which brought us to step 5. Connect each one with a line. So we connect them with a line. And then we did 2 things. Our last step is we're going to label the line and the intercept. And so what we're going to be doing today is we're going to be saying, hey, the intercept is where it crosses either the x or the y-axis. In this case, crosses at the exact same point. So let's give a shot at the next one. Let's create an XY table. And what I notice is that typically what we're going to do for today, later on we're going to learn a quicker, more effective method. Whatever variable has the slope coefficient in front of it, we're going to plug our values into that variable. So let's go ahead and plug our -2, -1, 0, 1, and 2 into the x, because we're doing something over here to the x. And this way, when we work it out, I'm going to say, okay, y is equal to 2 times my x of -2. And this is going to allow me to get a -4. I'm going to do that to each one of these. I'm going to plug each of those values into the x, and I'm going to do the thing that is sitting outside, multiply by 2. So I do the thing, and I get my x. So I have y equals 2 times, for my first one, 2 times -1, 2 times 0, 2 times +1, and 2 times +2. Each one of these, I get a different answer. And here's my new y values. And so when I plug in my left 2 down 4, what I notice is that the graph has changed somewhat in appearance. Instead of being directly diagonal, I'm noticing that my graph is a little steeper than normal. And again, this is because of the slope coefficient. My slope coefficient is a little higher, which means my slope is going to be a little higher. But like I said, we're going to go more into that in future lessons. I'm going to connect each point with a line. Then I'm going to label the line and the intercept. This line is called y equals 2x. It's the name of it. And I'm going to find where it crosses the axis, which is right here at 0, 0. There we go. So knowing what we know, I want you to pause the video, try number 5, and see how you do. Unpause it when you're done, and see what you did. Okay, let's make our XY table. I notice that my X has the things done to it, so I'm going to plug in my values in for the X. And for my Y, if I look at it in, pick some points, I'm going to plug them in, and then I'm going to solve it. I'm going to plug each one of these in. -3 times instead of x times -2. -3 times instead of x times -1. -3 times 0. -3 times -1. -3 times -2. And this is going to give me a 6, 3, 0, sorry. Those are positives. So what we're going to do is we're going to have a -3 and -6. These are my new y values. And so again, this is a steeper number, so I'm expecting a much more steeper line. But also that negative, what I notice is going to happen is that, first off, this is now so steep, it's off my graph. It's somewhere up here. So I can't even graph that one. I can only graph this middle one. So -1, 3, 0, 0, 1, -3. And then again, it's now gotten so steep it's off my graph. Y equals -3x. That's not the only thing that's changed. Both of my previous lines were going up to the right. This time it's going down to the right. And again, that's because my slope coefficient is now negative. Let's see, I've labeled my line, label my y-intercept. There we go. So what you might ask is, well, what happens if the slope-intercept is on a different variable? In this case, it's on the y. Well, you're going to do the same thing, except for you're going to do the process in reverse. Instead of plugging numbers in for x, I'm going to plug numbers in for y. -2, 1, 0, 1, and 2. And I'm just going to rewrite this equation, but instead of writing a y value, I'm going to write what my y was equal to. So x equals x equals 0 times y, so 0 times my y is -2. So 0 times a y value of -2. 0 times anything is just 0. In this case, 0 times -1 times 0 times 1 times 2. Each case, I'm multiplying 0 times the new y value, which is, in all cases, anything times 0, whatever the y value, is 0. So there's my new x's. So I have 0, -2, 0, -1, 0, 0, 0, 1, and 0, 2. Well, now I know it crosses this axis at all points, so I'm just going to go with when it crosses my x-axis, which is 0, 0. But then I'll go ahead and I'm going to connect all my points with a straight line. I'm going to label it. So I know it's 0y is equal to x, which in this case 0 times anything is just 0. So just 0 equals x. And there we go. So albeit this was a slightly different case because my coefficient was 0, it works for any of these. So what I want you to do is I want you to pause the video, give it a shot with number 9 and number 11. But remember, instead of plugging in for x, plug in your values for y both times and see how you do. Unpause the video when you're done and check your work. Okay, let's check it out. I have an x and a y. I'm going to plug in my values for y. I'm going to say, okay, in this case, it's going to be x is equal to 2 times the thing. X equals 2 times the thing, 2 times the thing, 2 times the thing, 2 times the thing. The first thing that I'm multiplying 2 by is -2. 2 times -1, 2 times 0, 1, and 2. I'll get -4, -2, 0, 2, 4. There's my new x values. I know at -4, -2, -2, -1, 0, 0, 2, 1, oh, and 4, 2. Connect them all with a line. Kind of missed that there, but I'm drawing in pen, so let's just kind of act like that went through that point. And label it 2y is equal to x. And I'm going to list that middle point. Again, I'm going to assume that that actually touched. I'm going to label it. So hope you did well on that one. Process is the same right here. Remember, instead of being a positive slope, because that was a +2, that negative just means it's going to flip. So we're going to get something with xy, -2, -1, 0, 1, and 2. And for each one of these, I'm going to say x is equal to -3 times something. -3 times my first something is -2. Second something is -1. Then it's a 0. Then it's a 1. Then it's a 2. And notice for my first and my last, I can't actually graph a a 6 on this chart. So I'm only going to be able to graph the middle 3, which means I'm going to have to go 3, -1, 0, 0, -3, +1. And so I create a horizontal-ish line. Remember, it is a diagonal line. So -3y is equal to x. I got it labeled. I'm going to label the center point, which is 0, 0. There we go. So today we're going to be graphing a line in slope-intercept form. This is an extension of what we've done previously, where we've just had a y and an x. And the idea is that we're now introducing this new concept that moves the graph up and down. We're going to call this concept the Y-intercept. And so we're going to notice a few trends with the data as we graph this. So let's graph it like we graphed it yesterday. And let's build an XY table. And let's list some values. We know that there's stuff going on over here with the x, so I'm going to plug in some values with the x. I take these 5 numbers, and what I'm going to do is I'm going to say, okay, instead of writing x minus 3, I'm going to write whatever that is, minus 3. So minus 3, minus 3, minus 3, minus 3, minus 3. So again, instead of saying x minus 3, my x is -2, it's -2 minus 3, which is going to give me a -5. Instead of saying x minus 3, it's going to be -1 minus 3, which is going to be -4. And then all the way down the line, we're going to take each one of these values and subtract 3 from it. So -3, -2, and -1, and these are actually my new y values right there. So what we're going to be doing is I'm going to be graphing this x and this y. So left 2, down 5. Left 1, down 4. 0, down 3. 1, down 2. 2, down 1. And I get a graph that looks something like that. So when I connect all these dots, I get y is x minus 3. I have that labeled. The only 2 things I need to include in this graph are 1, my y-intercept, which is right here. And that y-intercept is going to be at 0, -3. I'm going to include that. I can tell because I have a 0 in my table right here. And that if the 0 is on the x, that must be the y-intercept. And then I notice that the graph looks like it's going to be heading somewhere off in this direction. I kind of bent my line a little bit, so it's not 100% the most accurate. But let's try out and see if I plug in 3, so if I say 3 minus 3, do I get a 0? And yes, I do. So there's my other intercept. My intercepts are wherever there's a 0 in the graph, or a 0 in the table. So I'm going to list this as 3, 0. So a couple of the things that we're going to notice, and I want to take notice of these, is that if my intercept is at -3, do I see anywhere in this equation where there's a -3? Yes, I do. I notice that right here, this is my y-intercept. It's shown explicitly in the equation. The next thing we're going to notice is the fact that each one of these points seems to be increasing by 1. I'm going up by 1, going up by 1, up by 1, up by 1, and up by 1. I went up by 1 each time. And what we want to notice separately, let's do this in pink, is that my slope right here is going to tell me that rate of change. I have an understood 1 in front of the x, and I'm increasing by 1 each time. It's also evident by going up 1 over 1 each time. Awesome. So let's try that again. Let's do another one just like that, except for maybe a little bit more explicit this time. Let's actually put a number in front of the x. So let's build ourselves an xy table. Plug in the values, -2, -1, 0, 1, 2. And I'm going to plug these values into this. So 4 times that thing minus 4. And again, instead of saying 4 times x, I know what x is, I'm going to plug that into the equation and say 4 times -2 minus 4. 4 times negative 1 minus 4. 4 times 0 minus 4. 4 times 1 minus 4. 4 times 2 minus 4. Let's see what we get. So these are my new y's. So let's start right here. 4 times negative 2 is going to be negative 8. Negative 8 minus 4 is negative 12. 4 times negative 1 is negative 4. Minus 4 is negative 8. 0 minus 4 is negative 4. 4 times 1 is 4. Minus 4 is 0. 4 times 2 is 8. Minus 4 is 4. And so again, what we're noticing is the fact that what's going on each time we go to our next number. And it's probably most obvious towards here at the end. From 0 to 4, I went up by 4. I went up by 4. Up by 4. And basically, each time I go down to the next number, I'm increasing by 4. Where do I see that? Right there. So that's telling me how to build my table. The other thing that I'm going to note is that right here, this is my y-intercept. Do I have a 0, negative 4 in my table? Yes, I do. Awesome. So let's go ahead and graph this and see what it looks like. So if I have negative 2, negative 12, that's off the graph, as this one is off the graph. But this one right here, 0, negative 4, 1, 0, and 2, 4, those are all on the graph. Actually, just to make this a little more accurate, let's go ahead and get a ruler out. So y equals 4x minus 4. There we go. I have that. I need to label my two intercepts. This intercept is right here, so 0, negative 4. And then luckily I have my other intercept right next to the table, 1, comma 0. Okay. So now let's see if we can't expedite this process using what we've just seen twice. So let's take the next one and let's accelerate it a little bit. Let's build our XY table. But instead of picking random numbers, let's start with our y-intercept. Let's start with 0, comma 3. Okay? And then the next thing we're going to note is we're going to say, okay, if that was 0, comma 3, what's that number right there? Well, it's a negative 1, which means that this is going to go down 1. So my next one is 2. My next one is 1, 0, negative 1, negative 2. It goes down each time, down by 1, down by 1, down by 1, down by 1. And if we want to put that so that number decreases each time. And remember, this is every time I go over. So as I go over 1, over 2, 3, 4, and 5. So let's pop this on the chart. And so what I notice is as I go over 1, I go down 1. As I go over 1, down 1. Over 1, down 1. Over 1, down 1. Over 1, down 1. And I have a graph that looks like that. And so we have this. Y equals negative x plus 3. And that works out pretty well because it gave us our two intercepts. I have intercept number 1 and intercept number 2 at 0, 3 and at 3, 0. Awesome. Circle these points, and there we go. So we see the fact that we're slowly increasing the speed at which we graph this. Now, would there be a way to not even include the table? Can we notice a pattern with how we move on the graph to where we can just skip the table entirely? Well, try and go ahead, pause the video, try out the next one, and then unpause the video when you're done. See if you can't skip making the table entirely and just graph this. Resume it when you're done. Okay, perfect. So let's see how you did. So the first thing that I note is I'm going to note that this is my y-intercept. So I'm going to go ahead and I'm going to put a point on my y-axis at 4. I know that this, each time I move over, I'm going to go down by 2. So as I move over, down by 2. As I move over, down by 2. Move over, down by 2. Move over, down by 2. There we go. So I didn't need to make a table, but what I did do is I allowed myself to make the graph that we were after without even making a table. Y equals negative 2x plus 4. And even though I don't have a table to look for my intercepts, I can just look for them on the graph. I have one right here and one right here. That one is 1, 2, 3, 4 up, so 0, 4. This one is 2 over, so 2, 0. There we go. And that's how you graph one without even needing to make a table at this point. And so, knowing that, take a look at number 9 and see if you can figure out what's going on. Number 9 has a fraction. It's 1 over 2. Instead of, this is understood to be over 1, negative 2 over 1. What happens when we flip it? How do you think that's going to work? Pause the video, give it a shot, and see if you can't figure that out. Okay? So first off, we know that this is my y-intercept, which means I'm going to start at negative 1. Now, what we learned previously was that if my negative 2 is understood to be over the number 1, I know that each time I moved over 1, I went down 2. So if that was over, each time I went over 1, I went down 2. So let's take a look if we can't figure out what we're going to do with this. Well, if negative 2 was down, 1 is going to be up. So each time we go over 2, I'll go up 1. So let's go over 2, up 1. Over 2, up 1. Actually, if I want to go the other way, let's see if we can't go backwards. See, down 1, back 2, down 1, back 2, down 1, back 2. Let's include a new point right here. Down 1, back 2. Okay. Let's see how this goes. Y equals 1/2 x minus 1. I'm going to label my 2 intercepts right there at 0, negative 1. Over here at 2, 0. And so let's test out some of these points and see if we made it right. Let's see if this works. So I'm going to plug in this negative 2, because what I'm hoping to get is a negative 2. I'm going to plug in 0, because I have a point right there, and I'm going to plug in 2. And if I hit these 3 points, I know I've done it right. So let's plug this in. So 1/2 of negative 2. Actually, let's do this in a different color, so that way we can see what we're plugging in. Plug in the negative 2. 1/2 of 0 minus 1. 1/2 of 2 minus 1. Okay. Half of negative 2 is negative 1. Minus 1 is negative 2. Half of 0 is 0. Minus 1 is negative 1. Half of 2 is 1. Take away 1 is 0. And do I have a point at negative 2, negative 2? Yes. That checked out. At 0, negative 1? Yes, that checked out. And at 2, 0. Yep. So we know that by looking at the slope, we can figure out how far up or down we go, and the bottom number is how far over we go. So knowing how to do that, take a shot at number 11. Again, pause the video, see if you can't knock this through. Unpause it when you're done and see how you did. Perfect. Let's take a look. This is my y-intercept, which means I have a point sitting right here at 2. The next thing that we're going to note is that if this is my slope, okay, so I have a choice. What I'm going to do is I'm going to put the negative up top. So negative 2 over 3. We know that this is going to be down, and this is going to be over. Or another way to write over is right. So I'm going down 2, right 3. So down 2, right 3, down 2. Okay, I don't have any room left. But let's flip it. If I go the other direction, up 2, back 3. And if I go up 2, I know that I would have to show that as a positive 2 because I'm going up. And if I went back 3, I'd have to show that as a negative 3. So my question is negative 2/3 equal to 2 negative thirds? And the answer is yes. It doesn't matter which side you put the negative on, you'll be able to put the negative either way. It'll allow you to move up and left if you don't have room to move down and right. So I'm going to move up and left, get my point. Graph my line straight through. Y is negative 2/3 x plus 2. Labeled my line. I got a point right here that's at 0, up 2. A point right here that's over 1, 2, 3. So 3, 0. And there we go.